right, everyone, let's move on to page 3. Page 2 is a little too simple, so I expect you to do that on your own. Okay, good luck. And we're going to move on to page 3. Now, page 3 is more interesting because now you have to not only graph the f prime, but also f double prime. Ooh, okay, so now, you gotta just keep the same, rules, okay? For example, if this is a linear, you know that the slope of a linear is what? Let's try this one really quickly. What's the slope of a linear that goes horizontal? It's 0. So you gotta make sure that you graph. I'm gonna just do with a dotted line to mark that this guy and to indicate that this is a prime, okay? So yeah, f prime, done, you're done. Because what is the slope of this? Slope is 0, and you're graphing literally the slope. That's what you gotta keep in order, okay? Let's do some simple ones and then we'll move on. But this is the last page that I'm gonna go over with you. And then from then on, you're on your own, baby. Okay? All right, but I hope that this is enough, okay? All right, so be as natural as possible. Don't be so rigid, like, oh, positive, increasing, decreasing. Okay? You gotta just like move smoothly, okay? I think you can do this one on your own. I'll put up also the solutions for you so you can check it, okay? Let's move on to this guy here. Well, this guy is a little bit easy too. Okay, let's just do this one, okay? So now remember, this is the original, this is the original, this is the original, I repeat, this is the original. Now, this is a quadratic, so you know for sure it's going to be a linear of either this way or this way, not just horizontal and vertical though. So again, let's mark all the zeros. You see how this guy is a 0 here? It flattens out there. The slope here is going to be 0. So at around this point, the slope is going to be 0, which means that it's going to pass the 0. But what's happening from here until 2? So negative infinity to 2, it's going decreasing. Decreasing. Sorry about that. So it's negative. The slope is negative there because it's decreasing. But slope is positive after 2, so it's increasing there. So let's be as natural as possible. Be as natural as possible. You also know it's linear too, and the slope is same here and here, except this one's going downhill, this one's going uphill. So you know it's going to go something like this. Negative, right? That decreasing, that's the negative part, but then it passes here, so it's positive. That's going to be your f prime. If you want, you can use a different color, so have fun with it, or you can put dotted lines. Now, I'm going to put dotted lines for sure for the f double prime. Now, f double prime, don't forget about the original. Just focus on your new f prime. You're like, okay, what's the slope of this f prime? The slope is consistent all the way. What do you think this is? Maybe a 2, maybe a 1, whatever you agree on the slope for, that's what you're going to graph. Let's just pretend that this is a 2, slope of 2 linear. That means you just graph this guy here, slope of 2, and that's going to be your f double prime. Okay? Just have to psych yourself out by saying, okay, the actual slope, not the original graph. Slope, slope, slope. I'm going to give you a hard one to do on your own, number 8, but let's do number 9. It's a little bit more fun, that's why, okay? So we have a graph that's like this. It goes from here to here. Woo, it's a little wave. It's a little curve, right? But first thing first, okay? Let's mark all the zeros. So I see that this is a 0 here, this is a 0 here. That means the slope, it goes from increasing to decreasing here, and it hits a 0. Again, it goes decreasing and then it increases. That means it's a 0. So that means here it's a 0. Here it's going to pass a 0. You got to start with that. So it gives you some sort of guidance, right? All right, let's remember, this is the original. Just keep that in mind. So remember, it goes up and then it goes down and then it goes up again. And you know how it goes down and up? So you kind of have an idea that maybe this could be a cubic, even though I know that this is a periodic function, okay? Cubic-like in this, you know why? Because it's limited from 0 to 2 pi. Okay, so think about that. Look at the shape just on its own, okay? Now, you know it's positive and then a negative, right? So that means until here, it's going to be up here. It's going to be up here until here. But then until it gets here, it gets negative, right? It's negative. So you know it's going to go down. But what happens here? It hits a 0, and then it goes positive up. So you know it's going to look something like this. Okay, but let's actually not put an arrow because we know that this function does not continue on. Okay, let's just kind of do this. Okay, so as long as you have something like this, you're in good shape. Do you get it? How it goes positive? It's positive. It's up above the x-axis. And it goes under because it's negative, and then it hits the zeros. It has to hit the zeros because the slope became 0 here. And then it goes up positive, okay, after the 3 pi over 2. Okay, now for the exciting part. Oh, make sure you mark it f prime because you know that's the slope, okay? Now let's do f double prime. Remember, just focus on your f prime only. F prime only, okay? Okay, well, f prime is 0 here, right? It's 0 here. Okay, that means whatever the graph is, the f double prime is, it's going to cross over. But you see how it goes down. It decreases from 0 or wherever until pi. So it's decreasing here, it's increasing here. So from here, it's going to change from decreasing to positive. That means it's going to be negative here, but positive here. So then that's your f double prime. That's the kind of logic you have to use. Not so be so rigid, okay? Mr. B is crawling next to me, but he doesn't realize that the video can't see you because it's focusing on this. Okay. All right, let's move on to something more exciting. I'm going to leave this one to do on your own because it's more fun, and you can check your answer with me later, okay? Let's go here, number 13, okay? And this is the last example that I'm going to show you. Okay, so this one's a little bit tricky because here, it's given f prime. But you have to graph the possible, because you can't get it exact, but you have to get the possible f. Woo! Tricky dicky, okay? All right, so a couple of things about number 13 to recognize is that this is f prime. Don't forget that for yourself. You're going backwards now, so that means it went from up, down, right? So it's a cubic. It looks like it's a cubic. So you know it's a cubic, right? So that means you're going to maybe get a quartic, okay, possibility, a quartic. So kind of have those ideas. Quartic either goes down, down, or up, up, right? The end behavior, okay? All right. Okay, so remember, we're going backwards, okay? Let's go here. Let's start with this guy here. What can we focus on? You know these are zeros, right? You know these are zeros, these are zeros, these are zeros. What does that mean, though? When these are 0, what does that mean? Think. It doesn't mean that the slope is 0. What does it mean? It does mean that the slope is 0. It means the slope is 0, but when it says slope is 0, what does that tell you more? That it could either be a max or the min of the original graph, okay? Okay, but you know how this graph is a down, up? I'm sorry, it goes up, down? Okay, so think about what that could mean, okay? So let's think about a few things here. Now, it goes from here to here, it's decreasing, right? So from here to here, it's decreasing. I'm sorry, it's positive slope, right? Because we're graphing the slope here. From here to here, it's all negative, right? So that means it was decreasing from here to here. Now, from here to here, it was positive. That means it was increasing from here to here. And then from here and on, it's negative. It's decreasing from here to here. So all those things that you got to keep in mind, okay? Okay, so I'm going to try to do this best I can with a red marker, okay? Remember, this could either be like up here, right? It could be here or it could be here, because this could be a max or a min. Same with these two other points. But let's think. It goes plus, increasing. This means increasing to decreasing. Wait, it's increasing and decreasing. That means it has to be a max here. So what can you do? You see that little point that we predicted? We're going to just kind of sketch. Okay, but now, weird things happen here. It goes from decreasing to positive. And there's another 0 here. It goes from negative to negative, right? So that means it was decreasing in both places here. It was decreasing from here to here, so it's decreasing from here to here. But then what happens here? It's increasing, right? So it's negative, but then you got to decide, is this a max or a min? But it goes from negative to positive. Negative to positive, that means it was decreasing and increasing, right? So you know this one goes like this, okay? And then how about here? It goes from decreasing, it's increasing because it's positive above the x-axis, and then it goes negative. That means positive to, it goes from increasing to decreasing. That means it's, again, goes up this way. So it goes like that. Okay, so let's do that again, okay? Let's do that again. So again, here we have to predict whether this is a max or min. How do we decide that? Because it was positive and negative. Increasing, decreasing. So increasing, decreasing. Now here we have another quandary, right? We're like, what is this? But it goes from decreasing to increasing. So it's a minimum. That's a minimum. That's the minimum. This is the maximum. This is the minimum. right? Again, increasing, decreasing, that's the max. This is minimum when it goes decreasing to increasing. So again, this is a minimum because we knew that it went from decreasing to increasing. But what about this sucker here? He went from increasing to decreasing. So increasing to decreasing. So we know that this guy is at max here. So all these points go together. This guy, this guy, this guy, this guy, and this guy, this guy. So let me just show you that with a darker marker, maybe blue, okay? So again, this guy and this guy go together, this guy and this guy go together, and this guy and this guy go together. They should be a little bit better lined up, but remember, it's a possible graph, not an exact graph. So again, you see the quartic graph that happened here, and this is my cubic. Okay. Well, you know, maybe try one more, number 12 with you, okay? Remember, this is the original derivative function. Again, let's mark our 0. Oh, so it's 0 here. What does that mean? That means, oh, sorry, it's 0. So, no, we don't care about that 0. Sorry about that. We care about these zeros. What does that indicate about these 0? That means the slope was either here or here. It was a max or a min. Okay, so we care about whether it was increasing or decreasing here, right? From before this 0, it was increasing, right? It's positive. Okay, increasing. But from 0 to positive 1, it's negative. That means it's decreasing. But after 1, it's increasing. So increasing, decreasing. Okay, that's really important to know. But if it's increasing to decreasing, let's go back to our little thing again. It's increasing to decreasing. We know that this guy has to be a max because it went from increasing to decreasing. Increase, decrease to max. So we know that this graph will go something like this. And how about here? It's decreasing, right? It's decreasing until here. So we're going to decrease. But it's increasing again. So it's increasing again. So something like that would be the graph for that guy. And you have to mark that it's the original. Okay? All right, good luck, everybody. Everything is more or less same, but a little different. DYB. Good luck. I'm never going to give you the hardest cases to assess, okay? I just want you to have the basics, okay? Good luck. Bye.